All right, so Charlie said he didn't know how to do this. Have a seat, Charlie.
Okay. Thanks, Patrick.
Hopefully people who are watching the video already know the problem, because maybe my students at school will have looked at it. Let me make sure I'm writing on screen. Okay, so I'm going to say the problem and then I'm going to write. The problem is, how many times do the hour and minute hand of a traditional clock form a right angle during a 24-hour period? So traditional clock, what does that mean? That means a traditional clock, I'll go ahead and give away one of the times. What's one of the times that they definitely form a right angle?
3 o'clock.
3 o'clock. So that would be hour hand, minute hand. Okay. Does that show up pretty good? So, thoughts?
Intermediate value theorem.
What does that mean? So
Well,
what does the intermediate value theorem tell you?
Well, I mean, like, so if we know where it is 180 and we know where it's 0, right? Then we know where it's going to be 90 degrees too.
Ah, right. That's like
Yeah.
there's a monk at the top of the mountain,
Yeah. Monk at the bottom.
right? They have to cross.
Sure. Yeah, we don't know where they'll cross, but as
Right,
long as
okay,
we're just figuring out how many times they cross, right? I mean, that's sort of an equivalent problem.
So that's like a pretty mathy thing you're doing. Reformulate the problem. It requires training to
Okay.
do that sort of thing. I mean, it's fine. I'm just
Okay.
for the sake of the viewer. You should scoot a little bit more on screen.
Okay.
For the sake of the viewer, I'm just saying that immediately Charlie went to reformulating the problem. And I unintentionally added the marketing device, right angle. There you go. So how many times do the hour and minute hand of a traditional clock form a right angle during a 24-hour period? Okay, so what you're saying is, give me a time when they are at 180 degrees.
Yeah. So
I'm asking you.
okay, 9 o'clock or 9:15 or 3:45.
Ah, okay, so slow down.
Whoa.
Right,
Yeah,
okay, so what's happening?
We gotta be careful.
What's happening at 3:45?
6 o'clock, yeah, because it's tilted the 3 o'clock hand.
So a lot of people, I want to pause the discussion on this particular problem, and I want to talk about what it means to become alert to complexity. Okay, so what Charlie just realized was that when the minute hand is over here on 45, he was thinking at 3:45 that the hour hand would be pointing at the 3, but it's not. It's actually 3/4 of the way towards 4, right? Because 45 minutes is. So 3:45 is not 180 degrees. Now what happens is everyone who thinks about this problem becomes alert to this fact shortly after they really start thinking about it. I see like kids do the, 5-year-olds do this and adults do this. And you know what they say when they say to themselves like, oh, I can't do this, like, oh, this is so confusing, right? Oh, I got it wrong. But actually, when you realize this, you have become smarter. Even though you've realized that you've made a wrong guess, right? Like, in other words, you've learned something. You've learned the most important attribute of this problem. Unfortunately, learning it comes at exactly the time when you are the most wrong about the answer. And this is like the psychological dichotomy that, you know, people who are quote unquote good at math can live with, and those that aren't can't. Okay, so you've become alert to the complexity. The whole point of this is that we're not going to say, I'm so stupid, I can't figure this out,
Yes.
right?
Mhm.
But it's not so simple. In other words, to illustrate this, at 12 o'clock, they're pointing in the same direction. You would call that 0 degrees,
Mhm.
right? It's a 0-degree angle. It's not the case that 12:15 is not 90 degrees,
Sure.
right?
Mhm.
Is it less than 90 or more than 90? Don't answer. People are going to figure it out.